This is the Unit 5 review continued. We are now on question 27. Now, 27 has all these words, but there is no diagram. So the first thing that I need to do is draw myself a diagram. So I draw myself a diagram. This is going to be a triangle, and I have angle A is 65 degrees. I have angle B is 15 degrees. And I have angle C is 100 degrees. So from here, I need to answer the question. I want the sides to be in order from, excuse me, shortest to longest. So I'm starting with the short, and I'm going to the longest. So let's start with the short. The short side is across from the smallest angle. So here's my smallest angle. Across from that is this segment, and that is segment CA. Now, this is a multiple choice question, so the other way that this could be written is it could be called AC. So basically, I'm looking for either CA or AC. When I go to my answer choices, I can already eliminate answer choice H and answer choice G. Moving on, I want the middle side. The middle sized angle is 65. Across from that is this segment called CB. Now again, it could be called BC, either one. So I can go to my answer choices, and at this point, I can actually select the answer. The answer is going to be this one right here, but let's go ahead and finish the problem out. The long side is across from the long angle, the big angle. This is the largest angle. Across from that is segment AB. So AB or BA is the longest side. Next page. Question 28 has 3 different problems. Each one is multiple choice. Now, if we look at this first triangle, we can see we have 2 angles. But we know that all the angles have to add to 180. So 30 plus 62 plus x is equal to 180. When I solve that by taking 180 and subtracting 30 and subtracting 62, I get this last angle is 88 degrees. So I need to place the 88 in my triangle. From here, I'm going to answer the question. Question is, I want to list the sides in order from least to greatest. So I want to start with the smallest side and then go to the biggest side. So I start with the smallest angle. Here's my smallest angle, and the side across from that is the smallest side. So that is GJ. It's also known as JG. So at this point, I should be able to go to my answer choices and eliminate some. So I'm looking for GJ or JG, which looks like I only have one answer choice remaining. I'm going to go ahead and make sure that this is correct. The next biggest angle, yes, is G, and across from that is segment HJ. So HJ is my middle segment, or JH, and does that match? It does match with my answer choice. And finally, I have my largest angle, and across from that is my longest side. This side is called GH, so GH is the big side. It could be called HG. So I want to make sure that is right there. The next question in question 28, again, we are missing an angle. So the first thing I need to do is I have to figure out what this angle is. So 51 plus 56 plus x is going to be 180 degrees. So I take my 180 and I subtract out 51 and I subtract out 56. That leaves me with my angle measure that's missing at 73 degrees. Now again, we are going from the smallest side to the largest side. So to do that, I start with the smallest angle. So the smallest angle is right here, D, and across from that, the side is called EF. It also could have been called FE. So I can go look at my answer choices, and I can already choose my answer choice, which is right here, but I'm going to go through and make sure that this is correct. So move on to the next biggest angle, which is 56 degrees. The side across from that is the middle-sized length side, and that will be DE, which could also be written as ED. When I look at my answer choices, that is the middle side. Finally, I have the largest angle, and across from that should be the largest side. That side is called DF or FD, and when I look at my answer choice, it is correct. Moving on to the last part of question 28. We have another triangle missing an angle. So I know that 62 plus 41 plus x has to be equal to 180. So I take my 180, I subtract out 62, I subtract out 41. That leaves me with the missing angle is 77 degrees. And again, I'm going from smallest to biggest. So I take the smallest angle, which is 41 degrees. The side across from it is called QR. You can't see the Q, but it's right there. So my smallest is called QR, which could also be called RQ. So I go to my answer choices, and it looks like my answer should be A. I'm going to go through and do the rest of the problem. R is the middle-sized angle. Across from that is QS. That's the middle-sized length side. That could also be SQ, and it is the middle. The largest angle is the 77, and across from that is the segment here, which is RS. So RS is the largest side. It could also be called SR. Question number 29. Circle which three lengths can create a triangle. So there's a couple ways to do this. One is to just kind of go along the way and figure out, well, can these three lengths make a triangle? So for example, first of all, I can't have a length of a triangle be 0, so I can eliminate that one. Now, in order to create a triangle, if I add the two smallest pieces, that has to be bigger than the big piece. So in the circle right there, I've chosen 1, 2, and 3. If I were to add 1 and 2, I would get 3, but 3 is not larger than the biggest side, which is 3. So these three sides cannot form a triangle. So I move on. And again, you don't necessarily have to go in this order. I'm going to move on to 2, 3, and 5. When I look at 2, 3, and 5, I take the two smallest, and that should be bigger than the biggest. 2 plus 3 is equal to 5, and that is not bigger than 5. So these three lengths will not form a triangle. I'm going to move on. The next three I'll try are 3, 5, and 7. When I add the two smallest, is that bigger than the biggest? Well, 3 plus 5 is 8. Is 8 bigger than 7? And it is. So I have found the three lengths that will create a triangle. Now, this is not the only answer, because let's try another set. If I were to look at the next set of sides, 5, 7, and 10, if I take the two smallest and add them together, is that bigger than the biggest? 5 plus 7 is 12, and 12 is bigger than 10, so these three will also form a triangle. Additionally, they do not need to be three lengths that are next to each other. It just so happens in this problem that the three lengths that create a triangle are next to each other. So let's move on to number 30. We have two lengths are 4 and 6. Which segments below could be used to create a triangle? There are two correct answers, and you must circle both. Well, in this one, I could go through and check each one, meaning I could compare the 1, the 4, and the 6 if I was checking to see if 1 inch will work. I would add 1 and 4 and decide, is that bigger than 6? In this case, it is not. And I could go through that and do that with each of these choices. What I'm going to do, however, is I'm going to find the range of values for the third side. So to find the range of values for the third side, I start out with this, and I need to fill in the blanks. The first blank is when I take the two sides that I have, and I know that if I subtract them, that the third side has to be bigger than 2. So I know I have to be bigger than 2. So immediately I can get rid of 1 and 2 2 is not bigger than 2. For the other end of the inequality, I will add my 6 and 4, and that gives me 10. This tells me that it has to be, the third side has to be smaller than 10. So now I go over here, 12 is bigger than 10, 10 is equal to 10, which means here are the two choices that will create a triangle. And what that means is if I have the 3-inch, a 4-inch, and a 6-inch segments, those will create a triangle. Additionally, the 4-inch, the 6-inch, and the 8-inch together will create a triangle. Number 31, there's two different ways to solve that one. I'm going to use the range of values method. So if I have these two sides already, the question is, can the third side be 40 meters? Well, I'm going to do exactly what I just did. So for the first one, I'm going to subtract the two numbers, and 26 minus 15, that is going to give me 11, which means that the third side must be bigger than 11. That says than. Next, I need to add the two sides I've been given. And when I add the 26 and the 15, that gives me 41. And the third side has to be smaller than 41. So 40, does that meet the requirements? Is 40 bigger than 11 but smaller than 41? And it does. So first I need to answer the question, can the third side be 40 meters? That's a yes or no question. So the answer is yes, because 40 is between 11 and 41. Now, if you write that, the work here has to be shown. Okay? And again, that's not the only way to solve that one. That's just the method that I chose. Number 32, we have two sides of a triangle are 17 and 17. Write an inequality to identify the range of possible values for the third side, x. So we have this situation going on again. So starting with the first value, I would subtract the 17 minus 7 and get a 0. Now, this is actually okay. It just means that the third side has to be any number bigger than 0. It could be a half, it could be a fourth, it could be 15. Moving on to the other end of the inequality, we add 17 and 17, and we do that, we get 34. So this is our answer, that x is between 0 and 34. Next page. Number 33, we have two sides of a triangle are 2 feet and 1 foot. Write an inequality to identify the range of possible values for the third side, x. So I start by writing my inequality, and I'm going to fill in the blanks. For the first blank, I subtract the two lengths I've been given, and 2 minus 1 is 1. So that means x has to be larger than 1. For the other end, I add the 2 and 1, and that is 3, and that tells me that x has to be smaller than 3. Number 34. You should have seen something like this in class, and so what we are doing in this one is we need to match up Marcus, Tanya, Nicole, Stephen, and John with one. Each one of them gets one of these pieces of wood from the table, and everyone needs to make a triangle. I am going to do this using the range of values. So I'm going to set up my inequality for Marcus. Marcus has to be between 6 minus 2 is 4, and 6 plus 2 is 8. So Marcus has to be, the side that he needs has to be bigger than 4 and smaller than 8. So when I go to the table, bigger than 4, nope. Bigger than 4 and smaller than 8, yes. Bigger than 4 and smaller than 8, not smaller than 8, not smaller than 8. So that tells me that Marcus has to have the 7-inch side, and I can fill that in down here. Moving on to Tanya, I'm going to do the same thing. I'm going to write her an inequality, and she has to be between, I subtract 11 minus 5, and that gives me 6, and then I add 11 plus 5, and that gives me 16. So that tells me for Tanya, the piece must be bigger than 6, and it has to be smaller than 16. So I go back to the table. I know that 7 is no longer an option because Marcus has that one. And 3 is not bigger than 6. 10 is bigger than 6 and smaller than 16. 11 is bigger than 6 and smaller than 16. And 15 is bigger than 6 and smaller than 16. Now I'm going to erase the work that I have so that I can write down what the options are for Tanya. So Tanya's could either be the 10 or the 11 or the 15. Moving on to Nicole. Nicole has to be between what two numbers? So I'm going to come to the other side. And the first number is going to be 9 minus 4, which is 5. So Nicole's piece of wood has to be larger than 5. And 9 plus 4 is 13. The piece must be smaller than 13. So I come over to the table and I figure out what pieces could possibly work for Nicole. Well, 3 is not bigger than 5. 10 is bigger than 5 and less than 13. 11 is bigger than 5 and less than 13. And 15 is not less than 13. So we either have the 10 or the 11 for Nicole. Moving on to Stephen. Stephen's are 3 and 5. So for his inequality, we have 5 minus 3. So x has to be bigger than 2, and 5 plus 3, which is 8, and it must be smaller than 8. So we come back to the table, and we can identify which pieces are an option for Stephen. So for Stephen, the side has to be bigger than 2 and smaller than 8, and the 3 will work. The 10 will not, because 10 is not smaller than 8. The 11 is not smaller than 8, and the 15 is not smaller than 8. So that means Stephen has to have the 3-inch plank. I'm going to remove it from the table, and Stephen's is the 3-inch. And finally, we get to John. John, I'm going to put over here. His third piece must be between 12 minus 2, which is 10, and 12 plus 2, which is 14. So I need a plank that is bigger than 10 and smaller than 14. So again, I come to the table, and let's figure out what are the options for John. So is 10 bigger than 10? No, that will not work. Is 11 bigger than 10 and smaller than 14? Yes. Is 15 bigger than 10 and smaller than 14? No. So the only one that will work for John is the 11-inch plank. Then we can now move up to Nicole. Well, if John has the 11-inch, that means Nicole cannot use the 11-inch. She must use the 10-inch. At which point, we can now move on to Tanya. The 10-inch is being used by Nicole. The 11-inch is being used by John. So the 15-inch plank is the only one left for Tanya to select. Now each person has a wooden plank that will create a triangle with the pieces they've been given. Question 35. So we have a set of possible lengths for a triangle. And then we have to place them, whether we have a 30-60-90 triangle, a 45-45-90 triangle, a right triangle, but it's not 30-60-90 and it's not 45-45-90, a triangle, but it's not a right triangle, or these three sides don't make a triangle at all. So the things that I would start with is I would probably start with B. Now for B, for a 45-45-90, we know that our ratio is 1 square root of 2. So somewhere there has to be a side that has a square root of 2. So let's go to my answer choices, and the only one I have with that option is right here. And would that fit to have a 5, and a square root of 2, a 5 square root of 2 here, and that would. Those ratios would all be equal. If you cross multiply them, you get the same thing. So I have an isosceles triangle because it's 45-45-90. Two sides are equal. That's the 5 and the 5. And then I have a 5 square root 2. The next one I'd probably look at is the 30-60-90. So for the 30-60-90, we know the ratio is 1 square root 3 2. So I would be looking for something with a square root of 3. When I come over, there's only 1. So does it fit the ratio 12, 12 square root 3, and 24? If you were to cross multiply any of those fractions, they would come out to be true proportions. So this is the 30, 60, 90 triangle. So next things we're looking for are a right triangle, a triangle but it's not a right triangle, and something that's not a triangle at all. Now from here you can go any way that you would like. So if we started with this one, we can see if it's a right triangle. The largest side is 5, so that'd be my C. So I would be checking, is 3 squared plus 4 squared equal to 5 squared? And that is 9 plus 16. Is that equal to 25? And 25 is equal to 25. So this one is actually our right triangle. 5, 3, 4. So the next one we're looking at is this 6, 6, 12. So the question is, it's not a right triangle. I just have to decide, is it a triangle? If I add the two smallest sides, that should be bigger than the biggest side. Is 12 bigger than 12? The answer to that is no. This is not a triangle. So that would go right here. Finally, we have this last one. And let's just check and make sure that this is a triangle. I add the two smallest sides, and is that bigger than the biggest side? And 20 is larger than 12. Now I could also check with Pythagorean theorem to decide if it's not a right triangle, but this is not a 45, 45, 90 triangle, which would need to be if it had two sides equal. This is the end of the review. Please feel free to go back to any problem that you need if you have other questions. Good luck on your test.